This activity relates to the total surface area of a cuboid. The objective of the activity is to find the total surface area of a cuboid. Let's study the concept in hand first. So whenever you have to draw a cuboid, you always draw a rectangle first and then make an exactly same rectangle like this inside the first one and then join the corners, that means the vertices. So you get a cuboid. So in a cuboid, there are 6 faces and all these 6 faces are rectangles. We all know that the area of a rectangle is given by length times width, right? And let's mark the length, width and height in the cuboid. All these horizontal lines, they are lengths. All the diagonal lines, these are the breadths or the widths. And all the vertical lines, they are the heights. So H, H, H and H. So when you have to find the total surface area of this particular cuboid, you just have to find the area of the 6 rectangles and add them. So if you see the rectangle which is facing the observer, it has length and height as its dimensions. And there are 2 walls which faces the observer. So L times H, this will be the area of one such wall, and since there are 2 walls, it will be 2LH. Likewise, if you see the area of this wall which I am shading here, it contains breadth and height. So BH, and since there are 2 walls like that adjust opposite to each other here, it will be 2BH. And finally, we have the base, that means the floor, this one, which contains length and breadth, and since the roof is also similar to the floor, we have 2LB. So if you add all these, you will get the formula for total surface area. There's a common factor 2 which you can take out, and then in the bracket you can write LB plus BH plus LH. This is the formula for the total surface area of a cuboid. The material required to perform this activity are the general material like a graph paper, scissors, glue and the geometry box. Let's perform this activity of finding the total surface area of a cuboid now.
In this activity, we have a net which can be used to make a cuboid. You can see there are 1, 2, 3, 4, 5 and 6 rectangular shapes, and they are all connected to each other. Now, if you fold these along the dotted lines and try to make a cuboid out of it, you can definitely do that, because this will form a box-like structure and these 2 flaps will close this cuboid like this. So it is a cuboidal box. So as you can see now how the net is used to convert it into the shape of a solid cuboid. Now how do you find the total surface area of this cuboid? If you see the phase number 1 and 3, when you fold it, they become the vertically opposite faces. This is 1 and this is 3. And so, if you know that this part is the length and this is the height of the cuboid, then the area of third part is LH. Likewise, the area opposite to that, area 1, will be LH again. What about this second face? If this is L, then this is breadth, and therefore we have breadth and height in the second part, and likewise we have breadth and height in the fourth part also. So the area of this face will be breadth into height, and the fifth and the sixth, they are opposite faces, they will be like length into breadth. So we have 3 pairs of opposite faces, each having equal areas. So when you add 2LB plus 2BH plus 2LH and take 2 as the common factor, you get twice of LB plus BH plus LH as the total surface area of this particular cuboid. And that completes our activity on finding the TSA of a cuboid using a network like this.